So there we go. We see the 2. It's successfully run. No errors. All right. And now let's work on loading in our data set using pandas. So it's really easy. We're going to call this our data set games. This is going to be a pandas data frame. And it's going to just do pandas.read CSV, very appropriately named. And then just the name of the file here. And we should be good to go there. So let me add some comments for readability. Comments are always good. Load the data. All right. And let's actually just click Shift Enter there. We'll see if we can get that. We should. Yes, it does it very quickly. All right. So now let's explore this data set a little bit to see what we have in this games.csv vault in this file. So let's print the names of the columns in games. And so to do that, we'll just do print games.columns. And actually, let's do a print games.shape as well so we know how much is there. All right, here we go. So we have, oh wow, we have 81,000 games, 312, 20 different columns. We have ID, the type, name, year published, minimum players, max players, playing time, etc., etc. So the one that we're really interested in is the average rating here. This is what we're going to be trying to predict based off some of these other characteristics of the game. Like average weight here, weight is a function of the complexity of the game. So the higher the weight, the more complex the game is. This one's actually going to be important for our final predictions. All right, so let's explore this a little bit. Let's make a histogram of all the ratings in the average rating column. Average rating. All right, to do that, we'll use PLT, and we can just use the plt.hist. This will generate a histogram. And so we want games, but we don't want all the columns. We only want the average rating here. So just the average rating column. And then after that, we need to show the plot. So PLT, you need to do or the pie plot, you need a plt.show. So Shift Enter. All right, here we go. And this is kind of unexpected. So we see here we have almost 24,000, 25,000 games with an average rating of 0. So that's not really promising. But let's explore what this means a little bit more, because right now we have a lot of 0, and then we have a skew to the right where we have an average prediction of 6 just about. So let's do a print the first row of all the games with 0 scores. So we can see what's going on with these guys. And so we're going to use the .iloc method, which for data frames allows us to index by position. So we'll do a print games, and we'll have the games average rating again, where this is equal to 0. Those are the ones we're interested in, and we want to do .iloc. This is indexing by position. We'll just take the first one of those. All right, and to compare and contrast this, let's do a print the first row of games with scores greater than 0 as well. So we can see what's going on with those and if there's differences. So I'm going to just go up here. I'm going to highlight this, Control-C to copy, and then Control-V to paste. I'm going to change this right here. We don't want equals to, we want greater than. All right, so let's explore this. Shift Enter. So here's our first one where our review equals 0. So we have an ID, type, name, and then just no information. So we have one wisher. I'm not entirely sure what that means. Maybe somebody wants this game, but it looks like it was never published. 0 users rated, average rating 0. So this game doesn't exist, and that's why we're getting this information. However, this one, Twilight Struggle, published in 2005, and has all this other information. So average rating 8.3, pretty good, because 20,000 people actually rated it. So we want games where people have actually reviewed these, so that we don't have all of these zeros in our data. And once again, when we're doing machine learning, this is why it's so important to explore the data before starting, because sometimes you have information like this that is going to really impact your results in a negative way. So let's take care of that right now. What we're going to do is we're going to remove any rows without user reviews. So this is going to be pretty easy. So we want our data frame games again, and we'll just do games where the users rated is going to be greater than 0. So as long as somebody's reviewed this game, somebody's played it and reviewed it, we're going to assume it's okay. And then we want to remove any rows with missing values as well, because that is also going to impact our results. And this actually is going to be dropping the first axis, so we'll just do axis 0 here. Alright, and now let's make another histogram. And we'll do the average ratings again. So once again, this is plt.hist. So games, average rating. Awesome. And we need the plt.show as well. Shift enter. We'll see if this comes up. And it does. Here we go. Let's see that. Looks much better now. We don't have that 0, and everything looks more appropriate than before. You see we actually lost some here. We had some missing data, so this shape as well changed slightly. Alright, so let's move on. What we want to do is actually, first, this I believe was dropping the ID column. Let me do a game. We'll do a print games columns, and we'll run this again. Okay, so we have all the same information in there. We might want to go back and drop this ID column, but we'll see how it impacts our final results. The ID column doesn't really tell you any useful information about the game since it is assigned arbitrarily. However, you might get some biases, and it might result in actually overfitting if you include IDs in your machine learning training data. But for now, let's develop a correlation matrix. So what this is going to do is going to tell us if there are some strong correlations between some of these parameters in our data set. So we're going to use Seaborn for this, and this is a really cool way to do a correlation matrix. We've done it slightly different in the past, but this is a new way, so we'll see how this works right here. So we want a correlation mat, and we're going to develop this with simply the games.core, which is part of the pandas data frame. So this right here is the pandas data frame, and this is one of the functions that they provide. So we need a figure, so we'll do a plt.figure, and I'm gonna assign a figure size to this, simply so it looks nice. So that's that. And then here we have our Seaborn. We're gonna have the SNS, and we're gonna develop a heat map, and that's gonna be based off our core mat, or our correlation matrix, and we have some parameters here just to make it look nicer. So square equals true, so there's those. Alright, and let's try this one more time with a plt.show. See if this works. Alright, shift enter. So this will take a little sec. Okay, we have an error. Let's see what our error is. We spelled a word wrong. Alright, there we go. And here it is. So this is really awesome. And it's a heat map, so it's showing the correlations between our different parameters here, with 0.8 being the highest, and that being a white, and all the way down here in the black and about the 0, that is no correlation. So I see some pretty obvious correlations right now. No surprise, playing time is highly correlated with min playing time and max playing time. So that doesn't really tell us much useful information. But down here, we see some other things as well. The total weights is fairly highly, or the average weight. And remember, our average rating is the one that's important. So you see the ID is highly correlated with the average rating. And then as well, the average weight is fairly highly correlated. So some of these, like the min age is correlated with the rating as well as the base average rating. We're probably going to want to remove that because it's based off the average rating. So we're going to remove some of these because they don't actually tell us useful information. We don't want to have the type or the name or the ID, because this is all stuff that isn't actually characteristics of the game, but since they are highly correlated, are going to impact our results of our machine learning algorithm. Alright, so let us do that now. So what we're going to do, this is part of the dataset pre-processing, very important to machine learning. We're going to get all the columns from the data frame. And to do that, we need columns equals games.columns.toList is a very convenient function to generate a list, a Python list. And then what we want to do is we're going to filter the columns to remove data we do not want. So this is a very important step here. And so we'll have columns equals, and we're going to do a for loop in here. So C for C in columns, if C not in, and then here are the ones we're going to be excluding. So we don't want the base average rating because that's based off the average rating, so it doesn't really tell us useful information. We're also going to want to remove the average rating because we don't want to be trying to predict data that's in our training set. And we're going to remove the type, and we're going to remove the name, and then lastly we're going to remove the ID. So those are all data that we don't want. But we also want to store the variable we'll be predicting on. So to do that, we say target, and target being our target variable is going to be average rating. Alright, so let us just run a shift enter on this. So this will filter out the base average rating, the average rating, type, name, and ID. And now we're going to split the data sets and generate training and test data sets. So to do that, we already imported this, but it's from the sklearn. Here we go. Learn.cross validation. So you don't need to type this again. Just for readability, though, it'll be nice to have this down here so we know where our functions are coming from. So we are also gonna, right here, we're gonna generate the training set. And we're also going to set a random seed so that we can replicate these results. So we'll do trains games.sample. So fraction, we want about 80% of the data. So that's 0.8. 20% of the data for a testing data set is usually pretty standard. You want about 20%. So random state, we're just going to set to 1. Not so random. But this will allow us to reproduce our data and allow you guys to get the same results that I'm getting. Alright, so we want to select anything not in the training set. And we're going to put it in the test set. So to do that, we want test equal games, and so we'll have .loc. So this is going to be label-based indexing, and we're going to do the games.index.isinTrain.index. And instead of a parentheses here, I need a, oh, nope, that's right. Train is in, yep, there we go. So let me also print the shapes of both of these. So we'll do a train.shape so we can see if our data was divided up appropriately. So we'll do a test.shape as well. So shift enter here. And here we go. So this actually got removed in favor of model selection. So let's see if I can remove this, and it will be, there we go. Now it is not yelling at me. So I have 45,000 games in our training data and 11,000 in the testing data. So pretty big data sets here. And that is what we want to see. Alright, so I'm going to actually stop this video here. This is just setting up the data set. In the next one, it'll be a little bit shorter. We are going to dive into using our linear regression model as well as our random forest model and compare and contrast the results. So good job getting the data set imported from GitHub and pre-processed in a way that we can now use it for machine learning. So talk to you soon. Thanks.